whatever functions we were doing before, that was explicit functions. In explicit functions, we can write y in terms of x. Just remember, this is very important. You can, if you can write y in terms of x, okay, then it is called explicit function. It's called explicit function. For example, you have given, suppose x square y plus xy. This is a function. Okay, then you can take out y comma is equal to suppose 5. So you can write y, you can take common. So x square plus x is equal to 5, or y is equal to 5 upon x square plus x. Okay, so you can convert into y is equal to fx and then differentiate. Now you can differentiate. But in implicit function, we cannot write y in terms of x. If we cannot write y in terms of x, how to differentiate them? That's the problem. So how to find dy by dx? Okay. So in that case, we will use the chain rule. Chain rule will be applied. So for example, I will take implicit function where we cannot write. We will have the function of this fxy is equal to 0, and but y cannot be written as function of x. That you can understand by this definition. They are not going to ask the definition. So we take some examples. Suppose x square plus y square. You have given that x square plus y square is equal to xy. Now differentiate. If I will ask to differentiate, so previously what you were doing, you can, or if it is an explicit function, we can write in terms of y in terms of x, and then we can differentiate both sides, dy by dx. Okay, dy by dx of this and dy by dx of this function, dy by dx of 5 and x square plus x raised to power minus 1. Like this we can differentiate. But here we cannot do, can you write y is equal to fx? No, we cannot write y is equal to, y is not equal to function of x. And similarly, another example we can have, suppose you have cos x plus y. So inside angle you cannot take it out any number, any angle. So cos x plus y is equal to log xy. These are the examples of explicit functions, implicit functions. So how to differentiate these types of implicit functions? Okay, question I will take, then you can understand easily. First, I will take one question that if, or we can take this only. Chalo, we have to differentiate this one. So how to differentiate it? What we will do, we will differentiate first. We will not change anything in the function. What we will do, we will find the dy dx both sides. Differentiate, we will start from the function as it is given. So differentiate both sides with respect to x. So d by dx, here also you will write d by dx, and it is plus, so here product. Okay, I will write first. So in the starting you will write d by dx left side plus right side d by dx of xy. Now you have to use the formulas. If it is some formula, if it is a product formula, you can use the product formula, and y will be behaved as a function because y is a function. So we can use the formula d by dx will go inside x square plus d by dx of y square. Here the problem comes that this is a y square and we are differentiating with x. And in the starting I told you y, function of y cannot be differentiated with respect to x. But There is a way of doing it because it is a function. I will tell you. So here you have to use first product formula. So x you will leave, then differentiate d by dx of y plus leave y and divide d by dx of x, differential of x. Now see how we will differentiate y square on any dy by dx. Okay, we need to find what we need to find dy by dx. If this, the question is if this is this, then find dy by dx. Derivative means dy by dx. So we have to find dy by dx. Wherever dy by dx coming, no problem. We will leave as it is because we need to find this one. At last we will take it out from here. The problem comes here y square. How to differentiate? First I will tell you here d by dx. If you are just differentiating any other function, hmm? So you have to differentiate. The exact thing is we have to, like that I told you that we have to, when we were doing t substitution, I told you we have to multiply and divide by t. So here also we have to actually multiply and divide by dy and dy will come here and dx will go there. So in this way, this y can be differentiated with respect to y. Now it becomes y square with respect to y, and here one dy by dx will be extra. So in general, we can say we will write the differential of y square and 1 dy by dx will be extra. So that is equal to y square. The differential of y square is what? 2y square dy by dx. Got it? So this is the differential of y square. So whenever you are differentiating the y function with respect to x, 1 dy by dx will be extra always. So you get, what will you get? X square, differential of x square is 2x, nx and minus 1, and differential of y square, as I told here, you can see this differential here, or you can write here the steps, 2y square dy by dx, 2y square dy by dx. So first of all, you have to differentiate the whole function. Here already differentiated, here you are getting x into dy by dx, okay, cannot be further differentiated this part, and here you can have differential of x is 1, so y is left. This is the first step there when we have differentiated all the. Now after that always you will see dy by dx and some function where you will not find dy by dx. So all the terms which are having dy by dx you can take left side, other terms you can bring right side. So how will you write? Now you can, I'll write here. So you can take all the terms left side which are having the derivative dy by dx. So dy by dx, 2y square dy by dx is already left side, and one more term minus x dy by dx you have transpose on the left hand side. And right hand side, what is left? Right hand side is what? Y, and minus 2x will be taken on right hand side. Okay. Now you can take it out common dy by dx. Either you write in the starting of, you can write here. So when you take dy by dx common, what will be left? 2y square minus x into dy by dx is equals to y minus 2x. Okay, now this will come in the denominator. Therefore, you get the value of dy by dx. So this is the way of finding the derivative for implicit functions. So dy by dx is equal to y minus 2x. So you will start differentiating, and if it is a function of y, 1 dy by dx, don't forget it that you have to write dy by dx. Otherwise, you can multiply, divide in each step, dy you take here, and dy by dx. In the starting, I think I will suggest you to do this one. After that, you can write directly. So this is the way of doing the differentiation of implicit functions. So in our textbook, now we have implicit function. We take some questions from the textbook. Okay. So like exercise number 5.3. In 5.3, 5.3 question number 1, it is not implicit function. Second is implicit. So because it can be written y is equal to, but we will do like this only. By using the implicit function, we have to find the dy by dx in the following. Okay, so whether it is implicit or not, but we will go by this way always. If it is written y is equal to, no problem. Otherwise, whatever written, we will differentiate both sides. We can start same way. Question number 1, we have to find dy by dx. So we will write as it is 2x plus 3y is equal to sine x. This can be written actually sine x upon this, but this is the easy way. While differentiating both sides with respect to x, differentiate with respect to x, both sides. You should write, huh? Then 2 is common, so or you can write in the starting dy by dx. You write all the steps in the starting. Later on, you can do it directly. This is the dy by dx. What we are doing, the concept should be clear. That's why the dy by dx. What we are doing dy by dx both sides, and then we see that dy by dx can go inside because of sum. So 2 is a constant, then taken out. So dy by dx of x plus 3 is a constant. So dy by dx, and here right hand side differential of sine x is cos x, and here differential of x is 1. So we get 2 plus 3 dy by dx. So it is easy to get the differential by using this way. Instead of writing cos y is equal to, you can do this one, sin x minus, I want to write 3y is equal to sin x minus 2x, and y will be equal to sin x minus 2x by 3, and then differentiate. It is an explicit function. By mistake they have given here, but okay, we can go by using by doing the same way which we will apply for implicit functions. So dy by dx, so 2 can be taken this side and 3 we can divide. So therefore, on solving it, we get dy by dx is equal to cos x and minus 2. 2 is taken left side, so it will become minus 2 divided by 6. This is our answer. Got it? So then we can have next question. Question number 2. This is implicit function because 2x plus 3y is equal to sine y, because from the sine y we cannot take out. We cannot write y is equal to fx. So differentiate with respect to x, both sides. Differentiate, always write differentiate with respect to x. So I'll write directly now dy by dx will go inside. So 2 dy by dx of x plus 3 dy by dx of y, that is dy by dx, and dy by dx of sine y. Now you can see that sine y, we have to differentiate the function of y with respect to x. What we will do, we will multiply and divide by dy, and this dy will come here, and this dx will go there, dy by dx will be left, then sine y, differential of sine y, you have to write 2x, differential of x is 1, 3 dy by dx, we have to find out dy by dx, leave it here like this, and here what dy will come here in the next step. I'm not writing, I'll you can have the next step dy of sine y, and then dy by dx. Okay, and this dy by dx will left, and sine y, differential of sine y is equal to cos y dy by dx. Okay, now dy you can take out, you can bring left side, 3 dy by dx minus cos y dy by dx, and that 2 you can bring on right hand side minus 2, and then take out dy by dx common, 3 minus cos y into dy by dx is equal to minus 2. Okay, so finally we get therefore dy by dx is equal to minus 2 upon 3 minus cos y. Okay, so this is step I have taken. Okay, now we can have the last question of this, means 5.3, question number 3. Okay, so ax plus by square is equal to cos y. Differentiate both sides with respect to x. Differentiate with respect to x. So a is constant. We have to find the differential of x. B is constant. We have to find the differential of y square with respect to x. Here also differential of cos y with respect to x. So a differential of x is 1 plus b. Differential of y square is 2y, but generally the students are leaving to write dy by dx later on. In the starting, okay, they can understand, but when it will come in between differential equations or in integration, then that time they will forget. So that's why I am telling you again and again, you can multiply, divide, dy, and then you will not leave dy by dx. Here also cos y, differential of cos y is minus sin y, and 1 dy by dx will be there. This dy by dx comes, you can take left side. So you can write 2by dy by dx, dy by dx, and plus sin y dy by dx, and this a you can take right hand side is equal to minus a. So when you take dy by dx common, so 2by plus sin y will be left inside, dy by dx taken out is equal to minus a. Therefore, we get the derivative dy by dx is equal to minus a upon 2by plus sin y. Okay, got it? Any doubt? If you have any doubt, you can unmute yourself and you can ask the doubt. Any doubt, anyone? Are you understanding? Or those who are leaving the class, they will suffer. Okay, so any doubt? No doubt. So like this, we have implicit functions in this exercise, and now we see that whichever is looking difficult, we will take that question from the exercise. You can see this up to 6, 7, 8, 9, up to 9, up to 8. You can see the simple type of question. After that, you have inverse function, sine inverse, cos inverse, tan inverse. That we will do, but that is the derivative of inverse trigonometric function. Next part. So till here, I will take more questions. Okay, so it's very simple. Sine square, cos square, cos square. This 7th, 8th. Yeah, leave it. This question you can do it. We can start the derivatives of inverse trigonometric functions. So derivatives of now next formula, next part, that you must know, then you can do the other questions also. Derivatives of, now you have again 6 new formulas. Derivatives of inverse trigonometric function. Inverse trigonometric function. First, d by dx of sine inverse x. Inverse trigonometry we studied. Sine inverse x. So differential of sine inverse x is equal to 1 by under root 1 minus x square. Because sine square theta is equal to 1 minus cos square theta. From that it is derived. Similarly, second, if you have cos, sine inverse is this. Cos inverse will be same with the negative sign. So cos inverse, like differential sign is cos is minus. So here also minus will come, minus upon same thing under root 1 minus x square. Then we have differential of tan inverse x, d by dx of tan inverse x. Tan inverse x is equal to 1 upon 1 plus x square. Fourth, cot inverse, only the negative sign is introduced in tan. You will get the differential of cot inverse x will be equal to minus. You can write minus 1 or you can write in the starting. Does it matter? 1 plus x square, same thing. So negative sign. Similarly, this is what, why, because cot tan sec square theta is equal to 1 plus tan square theta. That's why it is 1 plus. And similarly, we can derive these formulas also. So d by dx of sec inverse x is equal to 1 by x under root x square minus 1. And similarly, cos sec inverse will be same only with negative sign, d by dx of cos sec inverse. So in pairs, you can remember these formulas. In pairs is equal to minus 1 by x under the root x square minus 1. So these formulas will be used. We can prove that sine inverse x. So this I'll prove that let y is equal to sine inverse x. Then you know that x will be equal to sine y. Sine will go here. This will become sine y. X is equal to sine y. Now differentiate with respect to y. Differentiate with respect to y, not x. So dx by dy is equal to d by dy of sine y. Now sine y can be differentiated with respect to y. So we can write dx by dy is equal to cos cos uh, cos y, correct? Cos y. Okay. And cos y, cos square theta plus sin square theta is equal to 1. So cos square y will be equal to 1 minus sin square y. Correct? Or cos y will be equal to under root 1 minus sin square y from the identity that you studied in class 10. So this can be written as dx by dy is equal to under root 1 minus sine square y. Why we are converting again? Because sine y is x. We have to find the answer in x. Differential of sine inverse x should be in x only. So dx by dy. Now substitute the value of sine y. Sine y is equal to x. So here it will be equal to under root 1 minus x square. Now taking the reciprocal, you can take the reciprocal of this. So reciprocal of this will be dy by dx. Dy by dx is equal to 1 upon under root 1 minus x square. And y is sine inverse x. Therefore, d by dx of sine inverse x is equal to, this is the proof. Like this, we can prove all the formulas. Sine inverse x is equal to 1 upon under root 1 minus x square. Okay. So, but generally what we are doing, we are not going directly by these formulas. We are doing the trigonometrical substitution. Here, we are doing the trigonometrical substitution. For example, I'll take one example where we are using the trigonometry. Generally, in 99% cases, we are using the trigonometrical substitution. If it is a cos inverse, then we can convert into inside cos. Like we can take, okay, one question we can take from this, then you can understand. So this is question number 9, first question okay, of inverse. So in this question, you can see that we are not going to do directly differentiation. First, we will convert, we will try to make inside sine. As I told you before also, we have to put the value of x so that inside we get sine, so that sine inverse sine something, sine inverse sine theta will be equal to theta. So you know that you should remember all the formulas that we did sine 2 theta, cos 2 theta, tan 2 theta, tan a plus b, tan a minus b, sine inverse, cos inverse, all that formulas that we studied already previous classes or this year, that you should remember. So this is for 11th class, we have seen that sine tan a plus b, tan a plus tan b 1 minus. So sine 2 theta, this is the formula for sine 2 theta here. Sine 2 theta is equal to 2 tan theta. Even then I will write here formulas whichever we are using, is equal to tan square theta. You remember this, you can easily do. So here x, if you will put x is equal to tan theta, then this will reduce to sine 2 theta. Then sine and sine inverse will cancel, then we can easily differentiate. So this is the way of differentiating. Otherwise, if you will use directly t substitution, it will be differentiated, but it will be very complicated. So we are doing by trigonometrical substitution. So we will put x is equal to tan theta. X is equal to tan theta. Now we are just substituting. After that, we will differentiate at last. But after simplifying, we can differentiate easily. That's why. So now you can put 2 tan theta upon 1 plus tan square theta. It will become very easy while doing like this. So sine inverse tan 2 tan theta 1 plus tan square theta is equal to sine 2 theta. And sine inverse sine 2 theta is equal to y is equal to 2 theta. Now theta is again you have to put, because this is the function of x, we have to bring it again in x. So tan will go there, so it will become tan inverse. So theta will be equal to tan inverse x. Okay. So here we can use y is equal to 2 tan inverse x. So this is the simplification of this question. So therefore we got y is equal to 2 tan inverse x. Now we can differentiate with respect to x both sides. So now differentiate with respect to x, both sides. Differentiate with respect to x. So left side you will get dy by dx is equal to 2 into d by dx of tan inverse x. Tan inverse x, differential of tan inverse x is 1 upon 1 plus x square. So its differential is 1 upon 1 plus x square. This 2 will multiply with 1. So 2 upon 1 plus x square is the answer. So in all questions, we will substitute the value of x, something, tan theta, cot theta, whatever is suitable to make inside sine. If we cannot make sine, we can make cos, because cos can be converted into sine by 90 minus theta. Cos can be converted into sine, sine 90 minus theta, cos theta. Sine 90 degree minus theta, cos theta. Try to make the same trigonometrical ratio inside. If outside is sine, inside also. Otherwise, you can make the, for sine, you can also make cos. Sometimes you have to make the opposite of that and then convert by sine 90 minus theta. Only in sine 90 minus theta, cos can be converted into sine and tan into cot. So that formula will be used here. So that's all for today.